So here's a section on triangle inequalities. This is going to be in the chapter that we skipped, and I do want to cover these two because they're kind of important. So the first thing you got to know is going to be theorem 5.10. Now these first two theorems you don't really need to know. You need to know they exist and how to deal with them. They don't have names, so you don't need to be able to call upon it as theorem 5.10 and stuff. All you really need to know, though, is that the biggest side of a triangle is across the triangle from its biggest angle, and the smallest side is going to be across from your smallest angle. So let's look at how to use one. All right, so first of all, I'm listing my sides from biggest to from smallest to biggest, so I need to look at my sides. So I know my smallest angle is across, or my smallest side, I'm sorry, is across from my smallest angle. So I'm going to look at angle C. That's my smallest angle because 37 is the smallest number. I'm going to look across from it. So I know that AB is going to be my smallest side. Then I'm going to look at my medium size angle, which is 55, and across from 55 is AC, so AC is my next biggest side. And then my biggest side is going to be across from my biggest angle, which here is 88. So across from angle A is BC. All right, so you got a few questions like that on your test, so make sure you know how to deal with those. Now we have theorem 5.11, which is basically the converse. So again, you need to know these exist, but you don't need to be able to call on them by name. So before we looked at our biggest angle to find our biggest side, here we're going to look for our biggest side to find our biggest angle. So our largest angle is across from my biggest side, and my biggest my smallest angle is across from my smallest side. Just keep big with big and small with small, and you'll be fine. So here's an example. All right, so now I want my angles from biggest to smallest. So make sure you're paying attention to the questions asking, because that is how a lot of you are going to mess up on your test, so just be careful. All right, so I'm starting with my biggest angle, and I know my biggest angle is across from my biggest side. Here my biggest side happens to be DE. 21 is my biggest number, so across from 21 is angle F. Then I'm going to look for my, Then I'm going to look for my medium side, which is 12. Across from EF is angle D. And then my smallest side is 11, so across from my smallest side is angle E, which is my smallest angle. And we're done. All right, this is a super important theorem that's going to show up a lot on your SATs and stuff like that. So make sure you kind of understand what's going on. All this is going to say is that the sum, all right, the sum here is we're adding. So the sum of any lengths of any two sides of a triangle must be greater than the third side. If you notice, it's not greater than or equal to, but it's strictly greater. All right, so we're going to be dealing with inequalities here. So remember, your greater than sign looks like that because your alligator wants to eat your bigger number. All right, but we are not greater than or equal to. Just keep that in mind. So here's the first way I can ask you a question on this. And it's going to be, can these lengths be part of a triangle? So I'm going to take 3 cases for every triangle. I'm going to take 2 numbers, I'm going to add them up, and they need to be bigger than the third. I need to show my work for these, so just be careful because it's the way you can lose points on your test. Alright, so let's start with example A. Here, my first set is going to be 3 and 4, and I know 3 plus 4 must be bigger than 5. So I'm going to simplify. 7 is bigger than 5, so I know I'm good. Now I'm going to take my other 2 numbers, 4 and 5. I know 4 plus 5 needs to be bigger than 3, So let's simplify and see what happens. 4 plus 5 is 9. 9 is bigger than 3, so we're good. Now I have one more set. I know 3 and 5 must be bigger than 4. So 3 plus 5 is 8, which is bigger than 4. So I do have a triangle. All right, easy enough. If they're not strictly greater than, then I don't have a triangle. So let's see what happens with B and C. With B, the first time I'm going to look at 2 and 7. And I know 2 plus 7 must be bigger than 11. 2 plus 7 is 9. 9 is not bigger than 11, so I do not have a triangle. I don't even care about my other two sides. Don't have a triangle here. All right, with C, let's start with 1 plus 2. I know 1 plus 2 must be bigger than 3. 1 plus 2, however, is 3. 3 is not bigger than 3, so I do not have a triangle. Alright, so with these, the way we're going to deal with finding my possible values of x are going to be to set up my 3 cases. Alright, I know 2 sides added together must be bigger than my third, so I'm going to take all 3 sets of adding 2 sides. So the first one I'm going to do, well, here's what I just said. Alright, so what I've written down are my 3 cases. I've added 3 plus 5, and I know 3 plus 5 must be bigger than x. I know 3 and x must be bigger than 5, and I know that 5 plus x must be bigger than 3. So what I'm going to do is I'm going to solve for x for all these inequalities. I'm going to cross out my negative answer, and then I'm going to put my inequalities together. Alright, so with this example, 3 plus 5 is bigger than x, so I know 8 must be bigger than x. Here, in order to solve for x, I have to subtract 3 on each side, so I know x is bigger than 2. And here, I need to subtract 5 on each side, so I know x must be bigger than negative 2. Again, I'm going to cross out my negative answer, and I'm going to put these 2 inequalities together. If you forget how to put your inequalities together, let's graph them on a number line. Alright, so in order to graph 8 is greater than x, I need to say x is less than 8. And then I graphed up my number line. And then x is less than 2 is graphed here. And then remember, when we look at a number line, we're going to look at the section of numbers that are overlapping in color. So I know my inequality is that 2 is less than x, which is less than 8. Easy enough, all you got to do. All right, here's our next theorem. This is our hinge theorem. Alright, all this is going to say is if I have 2 sides of a triangle that are congruent to 2 sides of another triangle, then my larger side is going to be across from my larger angle. So what I want you to do is take your leap pad, and I want you to kind of use the hinges that are on the leap pad. I want you to open it wider. What happens to that angle that's in between your screen and your keyboard? Alright, when you open that angle wider, the distance between the edge of your keyboard and the top of your laptop, or your leap pad, gets bigger. As you close your leap pad, that distance between the top of your leap pad and the keyboard gets smaller, just as the angle across from it that's in between your hinges are getting smaller. So what I do is I always think about a door or a laptop or your leap pad or something like that, something with hinges, and I try and make sense out of it with a triangle. If you're having a hard time with visualizing that, just let me know. But this is how we use it. So here I have 2 sets of congruent sides. I know AB is congruent to DE, and I know that BC is congruent to EF. So what I'm going to do is I'm going to look at the angles. I notice that 65 is bigger than 49, so I know that AC must be bigger than DF. All we got to do. If you forget your greater than or less than sign, remember alligators are hungry, so we can always think about my alligator wants to eat my bigger number. My bigger number here is AC because it's across from my bigger angle. Alright, so we also have our converse. I'm going to throw it to you really quick, and then we'll look at how to deal with it. So all this is going to say is that I'm going to start off with two pairs of congruent sides just like before, but now I'm going to look at the angles. My bigger angles across from my bigger side. So here I know AB is congruent to DE and BC is congruent to EF. So I know that I got two pairs of congruent sides. So then I'm going to look at the side lengths that I have. I have 13 and 9. I know 13 is bigger than 9, so I know that angle B is going to be bigger than angle E because it's across from my bigger side. All right, so just remember, keep big with big and small with small and you'll be fine. So here's an example. All right, so what we got going on here is first I want to try and use one of my hinge theorems. First of all, I have one pair of congruent sides because I know BC and CD are both 12. My second pair is my reflexive property. I know AC is congruent to itself. Now if you notice I'm looking at my included angles, across from my included angles are side lengths. So here I'm going to take a look at the measure of angle BCA and I'm going to compare it to the measure of angle ACD. I notice that 15 is bigger than 13, so I know that the measure of angle ACD is bigger than the measure of angle BCA because it's across from my bigger side. Now I plug in what I know. I know the measure of angle BCA is 2x plus 5 and the measure of angle ACD is 65. And then I solve for x, so I subtract 5 on each side, I get 2x is 60. Divide by 2 on each side, and x is less than 30. All right, all we got to do, easy peasy.